This is the practice exercise from page 48 of the textbook, calculating an atomic weight given isotopes, their atomic mass, and their relative abundances. So the first thing we need to figure out is what equation we're going to use to do this calculation. And the equation to use for this is that the atomic weight is equal to the sum of all of the isotope masses multiplied by their abundances. So if we take a look at the information given in the problem, I'm going to circle all of the masses in green. So there's one mass, there's another mass, and there's another mass. So make sure you're using the mass in atomic mass units, not the mass number. And then we're also looking at the abundances. And in this case, they give us the abundance as a percentage. Whenever we do these calculations, we're going to want to turn these percentages into decimals. So 92.23% is going to become 0.9223. 3.09%, 0.0309, and so on. Okay, so to actually set up this calculation, atomic weight is going to be equal to, now we have 3 different isotopes, so we're going to need to add together 3 different sets of numbers. So I'm going to start with the first one, the one that's the most abundant, and that's silicon-28. I know that it has a mass of 27.97693 AMU, and I know that its abundance 0.9223. I'm going to need to add that to the second isotope, so that's silicon-29. That's got a mass of 28.97649 AMU. This has only got an abundance of 4.68%, which as a decimal is 0.0468. And then the third one has a mass of 29.97377 AMU, and an even smaller abundance, 0.0309. Okay, so essentially we're going to have 3 different components. We're going to need to do the math for those and then add them together. Remember that this is a sum of all of the isotopes that occur. Now we should be able to estimate roughly where we think this answer is going to be. That'll help us double check to make sure our calculation's okay. And if you look, the most abundant isotope is silicon-28 with a mass of 27.97693. So that tells us that since that is so abundant, since 90% of the silicon that exists has that atomic mass, our atomic weight should be pretty close to 28. So that's a good thing for us to check as we go through and do the math. Alright, so I'm going to calculate each of these components separately, and then I'm going to add them together. Now when we do this, we want to pay attention to significant figures. If I take a look at the significant figures for this, the masses have a lot of significant figures. They're going out to a lot of decimal places here. So it's actually the fractional abundances that are going to determine what is happening with our significant figures. So here we've got 4 significant figures. Here we have 3 significant figures. And here we have 3 significant figures. So when we do our multiplication, we need to keep that in mind. If I go ahead and do the first one, I'm going to get an answer of 25.803. And I'm not writing absolutely everything that's coming off my calculator, but I am going to underline the ones that are significant so I remember that when I move forward. And these all have units of AMUs. If I do the next calculation, I'm going to get 1.3561 AMU. And again, I only get 3 significant figures, so I'm going to go ahead and underline those. Next calculation, I'm going to get 0.92619 AMU, and again I only get 3 significant figures here. Now since I'm actually doing addition here, so remember that this is the sum of all of these, so I'm adding all these numbers together, that means my significant figure rules are 2 decimal places, and if I look, the smallest number of decimal places I have is 2 decimal places, so I need to make sure that when I do my final answer, it only goes to 2 decimal places. So if I do all these calculations, I should get something around 28.085 AMU, remembering that I only get to keep 2 decimal places, so I'm going to round that to 28.09 AMU. So that should be my final atomic weight for silicon. And again, if I look, this makes sense. I figured out that the most abundant isotope was silicon-28 with an atomic mass of 27.97, so that's very close to 28, and since 92% of silicon has that atomic mass, it makes sense that on average, the average just a little bit higher than the 28 because we do have, about 7% of these other isotopes there.